In this video, I'm going to show you how to use synthetic division to divide a polynomial by a linear factor of the form x minus c. So here we want to use synthetic division to divide this polynomial 3x cubed minus 2x squared minus 3x plus 7. We want to divide that by the linear factor x minus 1. And of course, we know how to use polynomial long division. We could do this the long way with polynomial long division. But synthetic division is a lot faster, and we can use it whenever the divisor is in the form of a linear factor. Right now we're working with just linear factors of the form x minus c, but in the future we'll see how to extend this technique to work on any linear factor. So let's get a hang of this. Let's use synthetic division to divide this polynomial by this linear factor. So how we set up synthetic division is we draw a corner here. We draw a corner, and then the c value is what we put on the top left. So c, it's x minus c. So this is minus 1, so the c value is positive 1. You flip the sign of whatever comes after the x. This is negative 1. So to get the c value, you flip the sign and you get positive 1. So positive 1 goes here, and then in the rest of the top row we have the coefficients of the polynomial. Written in order of decreasing power. So the x cubed coefficient, that's the highest power, x cubed. That coefficient is 3, so we put it right here, put 3 here. And then the next one is minus 2x squared, so take that coefficient minus 2, put it right here. Then minus 3 on the x, put that minus 3 here, and then plus 7, and that's the last coefficient here. So now we've got the setup all ready to do our synthetic division. And we start off by writing a 0 in the first column. And now what we do is we just add down the column. So 3 plus 0, the result of 3 plus 0 is 3. Now our next step is to multiply. We multiply our c value of 1 and then times 3 and put the result up here in the next column. So 1 times 3, that result is just 3. And we continue this trend of just adding down the column and then multiplying to put our number in the next column. So we'll add down the column, negative 2 plus 3, that just makes, well, 3 minus 2 is just 1. And now we multiply 1 times 1, that's our result in the next column, that's just 1 again. And now we add down the column, negative 3 plus 1 makes negative 2. And then we multiply. 1 times negative 2 is just negative 2. And then we add. So 7 plus negative 2, that's just 7 minus 2, which is 5. Okay, so now the first few terms here are going to be the coefficients of our quotient. And our quotient is going to drop down a power. So the first term, before the first term was an x cubed term. Now the first term is an x squared term. So x squared goes here, x squared, and then the next term is an x term, so plus 1x, and then the next term is just a constant, so minus 2, and then you might wonder, what's this 5 doing here? So this 5 here is that's actually our remainder. And we'll see what that means in just a second when we use our diagram here. Now think back to polynomial long division when we talked about this diagram. The dividend divided by the divisor is the quotient plus the remainder over the divisor. And let's use the information here to fill out that diagram. So dividend, that is the polynomial that we have in the numerator. So that's the thing that is being divided. That's this right here. So 3x cubed minus 2x squared minus 3x plus 7. That divided by the divisor is just x minus 1, is equal to the quotient. This is our quotient right here. It's 3x squared plus 1x, so just plus x, and then minus 2, plus our remainder, so plus that 5, and that's over the divisor. So 5 over our divisor was x minus 1. So that is what our result means. Our result means that This row of 3, 1, negative 2, 5, that gives us our quotient and the remainder when we divide. So this is the result. This is our results right here. When we divide that polynomial by the linear factor, this is what we get. Our quotient, 3x squared plus x minus 2 plus the remainder of 5 over x minus 1. Here's another example, which is pretty similar to the previous example, but there are two things that are switched up a little bit. So we want to use synthetic division to divide this polynomial x cubed minus 5x squared plus 10 by the linear factor x plus 2. So first of all, we need to get our c value. And now this time, this is x plus 2, but the template for c is x minus c. So we have to convert this x plus 2 into x minus something. X minus what? So we have a plus, so we need the next number to be negative. We need it to be negative 2. X minus negative 2 makes x plus 2. And we need that because our template is x minus c. So c is negative 2 here. So that's what we put in our c. You can also think that we just take the opposite sign of whatever number comes after the x. So the number after the x here is positive 2, so we just flip the sign, it becomes negative 2, and that's what our value of c is. Okay, so that was the first thing that's different. The second thing that's different has to do with the coefficients of the polynomial. So just like before, it's ordered from greatest power to least power, and we start off just getting the coefficients. The coefficient of x to the third is just 1, and the coefficient of negative 5x squared is just negative 5. And then the next coefficient looks like it's going to be 10, but it's actually not. The reason it's not is because we're missing the x term in here. So let's scratch out the plus 10, and let's just write it over here. And there's also a plus 0x term that is in the polynomial. We didn't see it initially because it was written in condensed form, but if we want to get all the coefficients, we also have to include that 0x coefficient. So even though it's not there, we still have to write its coefficient. So we get a 0 coefficient for x, and then we can put in our constant coefficient, which is just 10. Okay, so now we've got it all set up, and we're ready to proceed with synthetic division just like before. So we start this off by just putting a 0 in the first column, and then we add down the column. 1 plus 0 makes 1. And then we multiply by c. We do negative 2 times 1, and that's negative 2, and that becomes the next entry in our next column. And now we're back to adding down the column. Negative 5 plus negative 2 is negative 7. And then we multiply to get the next result. Negative 2 times negative 7 is 14. So let's put that up here. And then add down the column. 0 plus 14 makes 14. And then multiply by that c value, negative 2. Negative 2 times 14 makes negative 28. And then add down the column, and we get 10 minus 28. Well, that's just negative 18. Okay, and now we're ready to put our results in our diagram. First of all, the first 3 coefficients become the coefficients of our quotient, and then the remaining coefficient at the end, that becomes our remainder. So let's put in our x terms into the quotient here. So originally we had an x cubed, and now this drops down 1 power, so now we're down to x squared. So we've got 1x squared, then minus 7x is the next power, and then plus 14, that's just the constant at the end. Okay, so now we've got all our information, and we can go ahead and put it in the big diagram here. So dividend over divisor. Dividend is just the thing that we were dividing. The thing that was being divided was our polynomial, and that was just x cubed minus 5x squared. We'll forget about the 0x and then just plus 10. All right, and divisor was just our x plus 2. Our quotient, we have that right over here at the bottom of our synthetic division. That's just x squared minus 7x plus 14. And then plus our remainder. So plus remainder is negative 18, so plus negative 18, and then that's divided by the divisor. And our divisor is just x plus 2. Now to write this a little bit more cleanly, we can also take the negative sign in front of the 18 and move that in front of the entire fraction. So let's do that. X squared minus 7x plus 14, and then minus our remainder of 18 over x plus 2. And there we go. There's our final result. This polynomial, or dividend, divided by this linear factor yields this result. X squared minus 7x plus 14 minus 18 over x plus 2. In these examples, we focused on linear factors of the form x minus c, but in the future we'll also learn how to use synthetic division to divide a polynomial by a general linear factor, say 2x plus 1 or 1 minus 3x.